Assuming we clear away the noise, the most captivating star I observe is one that could potentially stun our sky. This star is Betelgeuse. A massive red star, Betelgeuse is so enormous that if it were placed where our Sun is, it would extend out to the orbit of Jupiter. It is an unpredictable, colossal star on the brink of exploding. Though it may seem like any other star in the vastness of the universe, Betelgeuse is unlike most others due to its size and behavior. Betelgeuse has long been a source of fascination. Known as a red supergiant, it is roughly 20 times larger than our Sun. Astronomers and scientists like Brian Cox have speculated that it could one day go supernova, an event that could have dramatic effects. Recently, with the help of the James Webb Space Telescope, researchers have been closely observing Betelgeuse, raising questions about when and how it might explode and what impact that could have on Earth. Located in the constellation Orion, Betelgeuse is the second brightest star in the constellation and is famously red in color, which hints at its unstable state. Ancient observers, such as the Greek astronomer Timon, also noted the star's color, describing it as a reddish-orange hue. Today, we know that this star has been fluctuating in brightness, which makes it particularly interesting for modern astronomers. Betelgeuse is classified as a variable star, meaning its brightness changes over time. In 2019, it was observed that the star dimmed significantly, losing about 1.6 magnitudes of its usual brightness. This unusual behavior sparked extensive investigation by scientists, who speculated that it could be a sign that Betelgeuse is preparing to go supernova. Brian Cox, a renowned physicist, has even referred to it as a ticking time bomb, emphasizing the unpredictable nature of its potential explosion. The James Webb Space Telescope and other advanced instruments like the Laser Interferometer Gravitational Wave Observatory have been used to monitor Betelgeuse. Their findings continue to perplex astronomers, particularly because the star's unusual dimming and fluctuating brightness patterns don't entirely align with our expectations. These erratic changes suggest that Betelgeuse may be in the final stages of its life cycle, and could one day explode in a spectacular supernova event. Betelgeuse is about twice the mass of our Sun, and stars of this size are more likely to undergo a supernova. The star has been behaving in a strange way. Its brightness fluctuates at a much faster rate than it used to, and it's been observed to dim in cycles more rapidly. In February 2021, Betelgeuse experienced a sudden and significant dimming event that lasted for several months, further fueling speculation that it might soon explode. Despite all these signs, the exact timing of a potential supernova remains a mystery. The clues are intriguing, but experts still don't know when this event will occur. However, the ongoing observations continue to suggest that Betelgeuse is a star in a volatile, unstable state, possibly on the verge of one of the most spectacular explosions in the universe. The unusual dimming of Betelgeuse has sparked considerable concern and intrigue among astronomers. In late 2019 and early 2020, Betelgeuse, a red supergiant star, experienced a dramatic dimming, leading experts to worry that it could soon explode as a supernova. This sudden darkening was so extreme that scientists speculated it might be the precursor to a cosmic explosion within the next 100,000 years. However, Betelgeuse's behavior took an unexpected turn. After the dimming, the star began to brighten again, reaching 150% of its normal luminosity. This made Betelgeuse the seventh brightest star in the sky, catching the attention of astronomers. The dimming and subsequent brightening raised questions about the cause, with some speculating that the star's life was nearing its end. Betelgeuse, being a red supergiant, is already in the final stages of its life cycle. The red hue comes from its relatively cooler surface temperature of around 3,500 Kelvin, compared to the Sun's 5,500 Kelvin. Despite emitting less energy per square unit, Betelgeuse is much larger than our Sun and will eventually explode, though the exact timing is uncertain. Experts remain divided on the cause of the star's unusual behavior, with ongoing studies using cutting-edge instruments such as the James Webb Space Telescope, JWST. Since its launch in 2021, the JWST has provided critical data, revealing that the dimming event involved a massive mass ejection, 4 times larger than a typical coronal mass ejection from the Sun. The telescope's ability to observe different wavelengths of light has also uncovered dust clouds on Betelgeuse's surface, adding to the mystery. Though the star's brightening and dimming cycles are fascinating, scientists caution that predicting its supernova event is still a complex task. While some believe Betelgeuse could continue to shine for another 10 million years, others think it might explode much sooner, possibly within the next few years or even months. If Betelgeuse does go supernova, it will be the first time in history that we witness such an event with the naked eye, a spectacle last observed by Johannes Kepler in 1604. Despite the uncertainties, astronomers are closely monitoring Betelgeuse with advanced telescopes like JWST and the Hubble Space Telescope, trying to understand the precise timeline of its demise. If the explosion occurs, it will be a monumental event in the universe, releasing an immense amount of energy that will briefly outshine all other stars, visible even from Earth. While scientists are still gathering data, they remain cautious in their predictions, unsure when Betelgeuse will finally reach the end of its life. The full moon coincides with an exciting astronomical event. While this occasion is significant, it poses no immediate threat to Earth, as the star in question, Betelgeuse, lies over 600 light-years away. However, the upcoming explosion will provide a valuable opportunity for scientists to study the final stages of a massive star's life and the unusual phenomena that accompany such a violent event. Betelgeuse's impending demise is not just a scientific curiosity. It symbolizes the vastness and mystery of the universe. Stars like Betelgeuse play a crucial role in the life cycle of galaxies, enriching the cosmos with the elements necessary for forming new stars, planets, and potentially life itself. The death of such a star is not an end, but rather a transformation, as it releases heavy elements that will eventually help seed new stellar systems. As scientists continue to monitor Betelgeuse and its erratic behavior, they delve deeper into understanding its future. With each new discovery, the mystery grows, and our comprehension of the universe expands. Soon we may witness one of the most spectacular events in the cosmos: Betelgeuse's transformation from a massive red supergiant into a dazzling supernova. Until then, the sky will remain a canvas of wonder, with Betelgeuse shining brightly as a reminder of the transient nature of life in the universe. Researchers are particularly intrigued by Betelgeuse's peculiar behavior as it nears the end of its life cycle. This odd behavior raises questions about what might be causing such irregularities. It's important to note that not all stars end in a supernova. Smaller stars, like our Sun, will end their lives in a more peaceful manner, shedding their outer layers and leaving behind a white dwarf. However, Betelgeuse, being a massive red supergiant, will meet a far more dramatic fate, exploding in a magnificent burst, unlike the gradual dimming of smaller stars. Betelgeuse's sheer size, many times greater than the Sun, makes it a fascinating subject for study. If placed at the center of our solar system, it would extend beyond Mars' orbit, offering a sense of just how colossal it is compared to our Sun. Over its lifetime, Betelgeuse has consumed vast amounts of fuel, and as it approaches its end, its core is rapidly collapsing under the force of gravity. This collapse will eventually trigger the violent explosion of a supernova. As Betelgeuse nears supernova status, its core contracts and heats up while its outer layers expand and cool. This creates an unstable environment with fluctuating brightness. These changes, like the dimming event observed in 2019, are signs that the star is entering a phase of rapid transformation. This dimming may be caused by a surge of material from the star's surface, temporarily obscuring its light. Despite these fluctuations, Betelgeuse continues to emit light, though unpredictably, making it a captivating subject for study. The possibility that Betelgeuse could be a candidate for a nearby supernova has drawn the attention of space agencies and scientists worldwide. With advanced tools such as the James Webb Space Telescope and the Hubble Space Telescope, researchers are gathering a wealth of data on the star. These telescopes allow us to observe Betelgeuse in previously inaccessible wavelengths, such as infrared and ultraviolet light, providing insights into the star's internal processes. Furthermore, scientists are using sophisticated models to simulate the behavior of massive stars like Betelgeuse. These models help predict the star's future behavior and estimate when it might explode. While the exact timing of Betelgeuse's supernova remains uncertain, current data suggests it could happen sooner rather than later. Some predictions indicate the explosion could occur within the next few years, while others estimate it could take several thousand years. Regardless of the timeline, Betelgeuse's approaching demise will be a landmark event in the study of stellar evolution. Even though the explosion will not pose an immediate threat to Earth, it will provide scientists with an invaluable opportunity to observe the final moments of a massive star's life. By witnessing this event, astronomers will gain a deeper understanding of how massive stars die and what happens when they explode in a supernova. The remnants of the explosion will release new elements and materials that will enrich the interstellar medium, contributing to the formation of new stars and planets. In the end, Betelgeuse is not just a fading star. It is a cosmic clock, ticking down to a grand event. As researchers continue to observe this giant in the night sky, we are reminded of the awe-inspiring wonders of the universe and the delicate balance governing the lives of stars. Whether today, tomorrow, or millennia from now, when Betelgeuse finally reaches the end of its life, it will leave a legacy that shapes the universe for billions of years to come.